We've all been there, right? That sinking feeling. Your app is down, people are complaining, and you can't even get into your EC2 instance. It's got to be one of the most stressful problems you can face in the cloud. But hey, don't worry. In this quick guide, we're going to walk through a really calm, step-by-step process to get everything back online.
All right, so let's jump right in. Your first instinct, I know what it is. It's probably to panic, right? To just start rebooting stuff and hoping for the best. But trust me, a structured approach is going to be your best friend here. The real key is knowing what questions to ask first, and that is exactly what we're about to break down. And this right here, this is our guiding principle. Before we touch anything, we diagnose. Our whole goal for the next few minutes is just to figure out where the problem is. Is it inside my virtual machine, my OS, or is it something with the AWS hardware underneath it all? Answering that one simple question, well, it changes everything that comes next. So that brings us to the first big fork in the road. How do we even figure out if this is an AWS problem or a me problem? Well, thankfully, AWS gives us a really powerful tool to do just that, right inside the console. Okay, so here's the deal. The AWS console gives you two different kinds of status checks. And this is the key. You've got the system status check. If that fails, it means the problem is with the actual AWS infrastructure, the physical hardware, the power, the network, their problem. But then there's the instant status check. If that one fails, well, the problem is inside your own operating system. That one's on us. And this lays it out perfectly. It's a simple decision tree. You log in, you look at those status checks. Is the system status check failing? Easy. Just stop and start the instance. That literally moves it to a new, healthy piece of hardware. Boom, problem solved. But if the instant status check is the one that's failing, okay, that's our cue. Time to roll up the sleeves and start digging. All right, so let's say the instant status check failed. Or maybe, and this happens, maybe both checks are passing, but you still can't connect. Now what? This almost always points to the next likely suspect, the network. I like to think of it like you check the locks on your front door before you assume the house burned down, right? Same idea. So here's your quick 4-point checklist for the network. First, you've got your security groups. Then your network ACLs or NACLs. After that, check the subnet's route table. And finally, the IP address itself. Does it even have a public or elastic IP? It is absolutely wild how often the problem is hiding in one of these 4 spots. But let's be real. Let's focus on the most common one. Seriously, 9 times out of 10, if it's a network problem, it's a messed up security group. Somebody either forgot to open port 22 for SSH or 3389 for RDP, or, and I've seen this a million times, they've locked it down to an old IP address that you're not using anymore. Just check this first. It could save you hours. Okay, let's take this to the next level. So you've checked everything so far. AWS infrastructure is fine, your network looks wide open, but you still can't get in with SSH or RDP. So, what now? Well, now we need to find another way in, a sort of back door, to see what's actually happening inside the OS. Yeah, this is kind of where the standard playbook ends and the more advanced stuff begins. When the front door is locked, you got to find another key. And luckily for us, AWS gives us a couple of really powerful ones for just this kind of emergency. First up is the EC2 Serial Console. And let me tell you, this thing is an absolute game changer. It basically gives you command line access like you had a physical keyboard and a monitor plugged right into the server. It completely bypasses the network, which makes it perfect for fixing something like a broken firewall rule or a busted SSH service that's locking you out. Another amazing tool in the toolbox is AWS Systems Manager, or SSM. Now, the trick here is you have to have the SSM agent already installed on your instance, but if you do, you can use what's called Session Manager to get a secure shell. This is so cool because it works even if your SSH service is dead or your security groups are totally wrong, as long as the instance itself can still talk out to the SSM service. And hey, while you're trying all these different ways to get in, don't forget to look at your CloudWatch metrics. They can give you some major clues. They're like the instance's vital signs. You see the CPU pegged at 100%? That could be a runaway process just choking the system. High disk usage? Maybe the disk is totally full and nothing can even write to the logs anymore. It's a great way to see what might be wrong on the inside. Okay, but what about the worst case scenario? You've tried everything and the instance is just toast. It's corrupted, it won't boot, it's totally unresponsive. At this point, we have to shift our thinking. It's no longer about fixing the instance, it's about saving the data. This is your last resort. And here's how we pull it off. The whole process is kind of like performing an organ transplant, but for your data. You stop the broken instance, you carefully detach its hard drive, that's the EBS volume, and then you attach that same volume to a totally different healthy instance that we can call our rescue instance. From there, you just mount it like any other drive, copy off all your important files and logs, and then you can launch a brand new, clean instance to replace the old one for good.
So we've put out the immediate fire, but the job's not really done, is it? The real goal is to learn from this so it doesn't happen again. It's all about moving from being reactive, fighting fires, to being proactive.
And this is probably the most important takeaway of all. You gotta build this proactive toolkit before you actually need it. Go set up CloudWatch alerts right now to warn you about high CPU before the instance dies. Make sure the SSM agent is baked into every single one of your machine images. Take regular snapshots so you can always roll back to a good state. And for sure, use infrastructure as code, tools like Terraform or CloudFormation, so you can just rebuild a broken server from scratch in a few minutes.
And all of that leaves us with this one last question to think about. Look, fixing a broken server feels like a victory, and it totally is. But the real win is turning that painful, stressful experience into a stronger, more automated, and more resilient system for the future. So don't just recover, evolve.